Hello, in this video we will be discussing the Concept 5 Teacher Talk. Please make sure you have the Teacher Talk completed prior to watching this video. Set 1, we will be using the diagram to the right to determine which of the following pairs of angles exist, and we are going to be listing all the possible options. So our first thing is going to be complementary angles. Complementary angles are angles that add to 90 degrees. The issue here is we don't have any markings in this diagram, so there's going to be none. We don't have any complementary angles. We don't have anything that shows that we have two angles that add to 90 degrees. Supplementary angles, however, are two angles that add to 180 degrees. Just two to be considered a supplementary angle pair. So we have a few options here. We have angle 1 and 2 that form a line, and angle 1 and 3 form a line. You want to be careful here. Yes, angles 5, 4, and 3 would add to 180. So they do add to 180, but they cannot be considered supplementary angles because there's 3 of them versus 2. Linear pairs are going to be supplementary angles that do form a line. So supplementary angles are just two angles that add to 180, whereas a linear pair are two angles that have to be adjacent and add to 180. So in this case of our diagram, it's going to be the same answer. Vertical angles are angles that are formed by the same two intersecting lines. So in this diagram, that's going to be angle 2 and 3. Those are the only two angles that are made by the same intersecting lines. Angle 1 is not vertical to 4 or 5 because it has an extra little ray right there where it's broken up that larger angle into 2. Adjacent angles have to have a common vertex and a common side. So we're going to have a lot of options here. Angle 1 and 2 share the same vertex and they share the side. 1 and 3, 3 and 4, 4 and 5, and 2 and 5. So each of those groups are considered adjacent angles because they share a common vertex and a side. Set 2. Given a diagram, how can you tell whether or not two angles are complementary? So again, like I already discussed, there's going to be two options here. The two angles either form a 90-degree angle or their sum is 90 degrees. Given a diagram, how can you tell whether or not two angles are supplementary? Same idea, but now we're talking about the 180. So they either form a line or their sum is 180 degrees. And the type of angles that are always supplementary is going to be a linear pair. Set 3 states that angle ABC and angle CBD are adjacent, so that means they share a side and a vertex, and they're supplementary, so that means they have to add to 180 degrees. We're given the measure of angle ABC and the measure of angle CBD. So I'm going to go ahead and draw a diagram. Now here's my thing. If I know they're supplementary, that means I know my two angles could add up to 180. So I'm going to go ahead and make them a line and split my line into two. The other thing is, based off the name of my two angles, because the B is the center letter in the name of my angles, I know B has to be that common vertex. So what I've done here is I've drawn a line, I split it into two angles. The reason I have a line is because they're supplementary, and I've labeled them as the ABC, CBD, and put in the corresponding measures that were given. Now that I've done this, I can actually start to set up the angle addition postulate. So 8x plus 18 plus 10x equals 180, and we're going to combine our like terms and solve to get 9. Once we know the value of x, it says to find the measure of angle ABC and the measure of angle CBD. So I'm going to go ahead and plug in the value of my x to find the measure of these angles. And what you notice is that both angles are 90 degrees. Now our diagram is obviously not drawn like that, but we didn't know going into this problem whether it's going to be equal or not. In this case, because both ABC and CBD are 90-degree angles, we have a little bit of information about ray BC. We can say that ray BC is an angle bisector of our large angle ABD. And again, it's an angle bisector because the two angles are congruent.